x and y are constants. Okay, so first I'm going to simplifying the first equation. When you are integrating with respect to x, so you will get directly you will get phi equal to integration of y plus z with respect to x, comma here also phi equal to integral of z plus x with respect to y, and then phi equal to integral of x plus y with respect to z. Okay, so later we'll constant, indicating constant. So phi with respect to x, first one, so then implies phi equal to integration of y plus z with respect to x, nothing but yx plus zx plus integrating constant. This you have to remember and observe carefully, because I'm going to using one function that is f. So f of y comma z. Right, first I will complete this sentence, then I will explain what is f of y comma z. Okay, the second equation is phi equal to zy plus xy plus this one f of x comma z, and for third equation here I will write phi equal to xz plus yz plus f of, here it is x comma y. Okay, so let us observe here. Totally we got three different equations. I understood what integration? Any doubts is there for this expression?
No, sir.
What about others? Manish Kumar, Nishant, Pushpa, Monica. Any doubts is there?
No, sir.
Okay, then observe carefully. So why I am writing f of y comma z in the first integrating condition instead of constant? So I have already told. So we're integrating with respect to x, y and z are constants. Okay, so that's what I have written. In place of integrating constant, I have taken f of y comma z. So f of y comma z is also a constant with respect to x. With respect to x, while integrating with respect to x, f of y comma z is also a constant. That's what I have taken in place of integrating constant as f of y comma z. Okay, and also one thing you have to remember, where f is a function of y and z only, y and z, not x. Similarly, second one also, integrating with respect to y, x and z are constant. That's what I have written in place of integrating constant as f of x comma z. So here f is a function of x and z only, not y. And third one, x and y are constants, so integrating constant as f of x comma y. So f is a function of x and y only, not z. Okay, so for this one you can call it as equation number 1 for first expression, and second one is equation number 2, and third one is equation number 3. Okay, so now let us simplify any one equation. No need to simplify all the equations. So no need to simplify all the equations, but we have to write. So you are convenient, I'm going to taking the first equation. You can take any one equation. You can take any one equation after applying integration. Okay, so I'm going to taking equation 1 implies. So equation 1 implies what is there? Phi equal to yx plus zx plus f of y comma z. Now let us simplify the value of f of y comma z. So what is f of y comma z? So for finding f of y comma z, you can use equation 2 and 3. You can use equation 2 and 3 because I have already using equation 1 for writing the solution. So in that equation I got an integrating constant, that is f of y comma z. So I need to find this value, means integrating constant. That's what I am going to using equation 2 and 3. Equation 2 and 3. Suppose if you are taking equation number 2, then for finding the value of this integrating constant, so you can use equation 1 and 3. Okay, suppose if you are using equation 3 and for finding this integrating constant, then you can use equation 1 and 2. Okay, so any doubts is there? So any doubts is there?
No, sir.
Is it clear?
So I have a doubt, sir.
Okay. Yeah, tell me, Pa.
Sir, how you are getting this integrating constant as f of the function y and z?
So, see equation number 1. Here I'm going to integrating with respect to x only, no?
Yes, sir.
So, integrating with respect to x is nothing but y and z are constants, no?
Yes, sir. Y and z are constants.
Y z are constant. That's what I have taken. In place of c, I have written f of y comma z.
Okay, sir. So the c will be in the form of y
Because
and
f is
z.
also a constant, yeah,
Understood, sir.
a constant. Okay. Is it
Yes,
clear?
sir.
Similarly, equation 2 and 3 also.
Yes, understood.
Okay. Then what about others? Okay. Then let us consider equation 1, and in that we have one integrating constant. And so for finding the value of that constant, then you can use the remaining two equations. Okay. So I'm going to using the first equation. In that I have got f of y comma z be a constant. So then let us find f of y comma z using 2 and 3 only. Okay. So then implies, and also I have told what is f of y comma z. F of y comma z is nothing but f is a function of y and z only, not x. F is a function of y and z only, nothing but what? The expression which is in the form of like either y or yz, y minus z, and so on. Not in terms of like z. Like suppose if it is yx also, it is not a function of f of y comma z. X term should not be there. X term should not be there. Okay. So see here in equation 2. Now you can tell me the value of f of y comma z. Anybody can tell me? The function should be in terms of y and z, or y or z, not in terms of x. Okay. So here zy is there now in equation 2. F of y comma z you can write as zy. Correct now? Okay. In equation 3, and another one means that is x comma y, xy, but here x term is there. But f of y comma z says that it should be contained only for y or z, not x. Okay. So I have got one term that is zy nothing but yz in the second equation, then plus in third equation also xz is there, but x should not be there, and yz is there another one. So if the values, if the terms are repeated, then you can write only once. You can write only once. Okay. That you have to substitute in the first equation. So then implies, therefore phi equal to yx plus zx plus yz is the required solution, or xy plus yz plus zx.
Excuse me, sir.
Yeah.
Sir, I am not getting from the last step, f of y comma z, how we have got yz.
F of y comma z, I have already told I am using equation number 1. So for
Yes,
finding
sir.
that constant, we need to use equation 2 and 3.
Yes,
Okay.
sir.
Suppose if you are using equation 2, then we need to find this constant by using equation 1 and 3. Similarly, third equation also. So our convenient, I am going to using the first equation. Okay. So here
Yes.
I have got an integrating constant that is f of y comma z. F of y comma z nothing but what? F is a function of only y and z. Okay.
Yes, sir.
Only y and z. So let us simplify the value of f of y comma z by using equation 2 and 3. And x term should not be there. Those values you can treat it as a y comma z, f of y comma z. So here how many values are there in equation 2? Zy is there, no? There is
Yes,
no x
sir.
term here. Okay, there is a one value, and xy is there, but here x is there. We should not take this one. Suppose if it is only y, then you can take, but here what is the x into y is there.
Yes, sir.
This is not the value of f of y comma z. Okay. Similarly, in equation 3 also, this is also not the value of f of y comma z. But here the values are repeated. No, the terms are repeated, yz and yz.
Yes, sir.
So if the terms are repeated, then you can write only once.
Okay. If it
So
is not repeated, then we'll write both the terms, right?
yeah, you can write. Suppose see here. Suppose if it is in place of yz, only z is there, means you can write like yz plus z you will get.
Okay.
Okay, and also you should write the sign. Suppose if it is negative sign, also you can write negative sign.
Okay, sir. Clear.
Okay, understood?
Yes, sir. Yes, sir. Thank you.
Okay, others. What about others? Okay, then write down. Oh, here only. Okay, I can write down. Any doubts is that you can ask me. Simply you don't write. Because this type one sum is compulsory. If you can check the model question paper or previous year question papers also. For finding scalar potential, and as you have to remember the condition, that is del phi is equal to vector f. So solenoidal means the divergent, and irrotation means the curl. So write it fast. Over. Someone is disturbing Ranjan.
Yes, sir.
What is the disturbance?
Oh, sorry, sir.
Just write it fast. Over.
Yes, sir.
Yes, sir.
Okay.
Yes,
We'll
sir.
write down this one. Have you written the complete solution?
Sir.
Yeah.
Yes, sir. Done.
Okay. Others, any doubts is there? Others, any doubts is there?
No, sir.
Okay. Okay. I will give one problem which is similar. So can try to solve this one. So then I will check how much the people are understanding. Okay, write down. The next one. Show that vector f equal to So that vector f equal to two xy square plus yzi plus 2x square y plus xz plus 2yz square j plus 2y square z plus xy into k is a conservative force field and find its scalar potential. Okay, show that 2xy square plus yz I plus 2x square y plus xz plus 2yz square j so 2y square z plus xyk is a conservative force field and find its scalar potential. So first you have to prove the first result then the second one I will explain. Okay. Over. Anybody has proved the first condition?
Yes, sir.
Yes, sir. 0.
Okay. 0. What about others? So any doubts is there? Then second one, they didn't give the condition no for finding scalar potential. Okay, find its scalar potential means you need to find only for del phi equal to vector f that you have to write. Okay, so for finding scalar potential, del phi is vector f. Okay, now what is write down the conditions of what is del phi and what is vector f. Write down the conditions of what is del phi and what is vector f.
Sir,
Yeah.
so the answer is x square y square plus xyz plus y square z square.
Okay.
Correct, na, sir?
What is the answer?
Sir, x square y square plus
Okay, answer I don't
xyz.
have.
Which one?
Wait, I will prove. What about others?
Yes, sir. Correct, sir.
Okay, see, who are not getting the answer, just listen. So, is it visible now? Okay, so the value of we are equating, what will you get? Del phi by del x equal to, what is the function of coefficient of I, 2xy square, 2xy square plus yz. Okay, similarly, del phi by del y equal to 2x square y plus xz plus 2yz square. Okay, and then third one here I write del phi by del z equal to, what is the coefficient of 2y square z plus xy, 2y square z plus xy. Okay, so I'm going to integrating the first one with respect to x. So directly I'm writing the answer, that is phi equal to, with respect to x means 2. So finally I will look at x square y square now plus xyz plus f of y comma z, equation 1, and with respect to y, phi equal to, here also x square y square plus xyz plus y square z square plus f of x comma z or z comma x, equation 2, and then with respect to z, therefore you will get phi equal to y square z square plus xyz plus f of x comma y, equation 3. Okay, did you got the same values of phi, equation 1 and 3? Did you got the same equations 1, 2, 3?
Yes, sir. Same.
Okay, so therefore equation 1 implies phi equal to x square y square plus xyz plus what about f of x comma y, f of y comma z, f of y comma z by using equation 2. So y comma z means it's only contains y and z, or y or z, that is y square z square. In equation 3 also same is there, so you can write only once, so that is x square y square plus xyz plus y square z square is the correct answer. What about others? Did you got the same result?
Yes, sir.
Okay, and those who are not getting the answer, they can write down. If you're not getting, write down the answer, write it fast. Okay, so then write down the next one. Find the value of constant. Find the value of constant find the value of constant A such that vector f equal to axy minus z cube I plus a minus 2 x square j plus 1 minus a x z square k is irrotational and hence find a scalar function. Find the value of constant a such that vector f equal to axy minus z cube I plus a minus 2 x square j plus 1 minus a x z square k is irrotational and hence find a scalar function.